Hey guys, it's Miss Tuis again, and today we're going to be talking about chemical equations. So just as a recap from the first week that we started doing this, chemical formulas are going to be a really important aspect of chemical equations. So just a reminder that when we have a formula, every capital letter we have represents an element, okay, a different element. So this is the formula for H2O, water. And subscripts refer to the number of atoms of a specific element, and they come after the element they refer to. So in this case, this 2 tells us that there are 2 hydrogen atoms in this molecule. And notice that there is not a subscript after the oxygen. That means that there is just one atom of oxygen in the molecule of water. We do not have to write the 1 because it is implied, okay? So that's why the formula for water is H2O, and it is made up of 2 hydrogens and 1 oxygen, okay? So 2 hydrogens and 1 oxygen. So what is a chemical equation? A chemical equation is a symbolic representation showing the kind and amount of starting materials and ending materials in a chemical change or a chemical reaction. So that's what we were talking about last week when we talked about physical versus chemical changes. A chemical equation is how we show that a chemical change has taken place in terms of what happens with the atoms themselves. So with that, let us talk about what are the parts of a chemical equation. So the starting materials, so the materials you have on the left half of this equation. So usually what we do is we split it down the middle between the, where the arrow is. And the left half is the starting materials, and they are called the reactants because they are the things that will react together. Okay, so these are the things that will react together. The ending materials are called the products because this is what is produced during this chemical equation, chemical reaction. And then the arrow, we have a special word for that. In science, we call this arrow, we use this arrow to represent yields. Okay, so that means that the reactant yields these products. So it's just kind of a fancy way of saying when we mix this stuff together, they make this stuff, okay? It's really important to understand what these big numbers in front of the formulas are. So we've talked about these little numbers. These are our subscripts. And they refer to the number of atoms of that element. Okay, so this 2 is talking about this hydrogen atom. This 2 is talking about this hydrogen. This 2 is talking about this hydrogen. Coefficients are the big numbers, so they're big, so they're full size, and they're found in front of the chemical formula. And they represent the number of molecules needed for that reaction to take place. So for this reaction to take place, you need 2 hydrogen molecules. You need 1 oxygen molecule. Notice that there's no 1 in front of it, but that still means that there's 1 oxygen molecule. And that will produce or yield, 2 water molecules, okay? You'll understand, we'll talk about why we have to have these numbers in front later, but right now I just want us to get familiar with the fact that they're there and they have a purpose, okay? So here is a review for kind of all the things we just talked about. Here we've got a chemical equation here in words, in letters, right here in the front. And this is methane gas burning with oxygen, yielding or producing carbon dioxide and water. So we've also got it in the models down here. We see that there is 1 molecule of CH4. We have 2 molecules of O2, okay, so we've got a 2 here, and that's why we have 2 here. We've got 1 molecule of CO2 and 2 molecules of H2O. Methane, CH4, and oxygen are the reactants. CO2 and water, H2O, are the products, okay? And lastly, again, I want you to pull your attention to the coefficients. Notice that this is the picture, okay? But there is not a coefficient in front of CH4. That's because we only have one of them. If we only have one, it's implied, okay? Just like in science or in math, if you've got x plus 3 equals 5, how many x's do you have right now? You only have one, but you don't write the one in front of it. It's implied, okay? You only need to write a coefficient in front of your math equation if it's more than one. All right, so that would change the x. But if we only have one x, we don't put a 1. Just like when we have a reactant or a subscript, we do not put the 1. It's always just, it's an invisible 1. Think about it that way, okay? So there's an invisible 1 here in front of the CH4, an invisible 1 in front of the CO2, and those are the coefficients for this equation, okay? So let's do some practice. Here we've got a model showing the reaction of hydrogen, chlorine to create hydrochloric acid, which is the stuff in your stomach that breaks down food. And let's go over here to this actual equation. What coefficients might we need to add? Okay, so pause the video if you need to and take a guess. So if you put a coefficient of 2 in front of the HCl, you are correct. We do not need a 1 in front of the H2 or the Cl2 because, again, there's only one molecule of each of those, therefore it's implied, okay? Here is another example of a chemical equation. We've got the model represented with the atoms as well as the word equation here. And the question is, which of the following correctly list the reactant or reactants? A, 2Ca, B, 2Ca and O2, C, 2Ca and 2CaO, or D, 2CaO. Pause the video and give yourself an answer. If you told yourself that B was the correct answer, then you were correct. Reactants are the things on the left-hand side of the reaction. These are the things you start with. So starting material. Okay, this side is called the products. All right, so this is the product. Next question, which of the following is the correct chemical equation for this reaction? So it looks like we've got, let's figure out what this is. This is H2, so we've got H2 involved, O, 2 of them, so this is O2. H2O, so this is H2O. You want to make sure that you compare the formulas, the order, and the coefficients. So go ahead and pause the video. If you were able to eliminate, let's see, so we should have had a coefficient of 2 in front of the H2, so that would have eliminated C. This one has them in the wrong order. This has H2O, so yes, it has a 2, but it has H2O as the reactant rather than the product, so this is incorrect. Then both of these have 2 H2s, so you need to make sure that which one has the 2 H2Os, and that would be B is the correct answer, because this one does not have the coefficient in front of the H2O. And lastly, this is the chemical equation for photosynthesis. This is what plants do. How many molecules of C6H12O6 are produced in this reaction? Pause the video and give yourself an answer. So if you said 1, you are correct because it is here in the equation. There's no coefficient, which means there's an invisible 1 in front of it, all right? It cannot be 0 because if it was 0, this formula wouldn't even be in the equation, all right? If we didn't produce any of it, why would we put it in the chemical equation, all right? And I do believe that is all I have for you guys. So I hope this helps, and I will talk to you guys later. Thanks. Bye.